Okay. Hello, guys. I guess we can get started. So for today's webinar, we'll be talking about far shading losses, how to understand them, and how to maximize your solar power output. So just to give a brief introduction about myself, my name is Altair Veiga. I'm a principal consultant. I am passionate for renewables and a sustainable world, and I'm also part of the customer success team here at the RatedPower. So in case you guys were not familiar with Pulse, so basically Pulse is a 2-day event happening in Madrid, Spain, which will have professionals from all over places to discuss the transition to a sustainable world, any upcoming challenges, any business opportunities, and as well as other related topics. So if this is something that you're interested in and you would like to have more information about it, please get in touch with us. You can access our website, www.ratedpower.com, and we'll be able to get you sorted. Alrighty, so those are basically the four over today. So we'll start with the shading sources, the definition of far shading and horizon profiles. We'll also be talking about how to optimize far shading losses in PV design. And in the end, we'll also be able to answer any Q&A. So please feel free to drop any questions in on the comment section, and in the end, I'll be able to answer those. So starting with the first one, shading sources. So here we can see basically the three most common sources of shading. Right? The first one regarding the meteor conditions. So this is nothing more than, let's say that the sky is very, very cloud, right? So in those particular times, the sun will be blocked by those clouds, and that light will not reach the PV panels. So this is one type of shading due to meteor conditions. And then we also have the far shading, which is going to be, as the name suggests, it's regarding far shading. So any far element that will be causing any shading to our PV plant. This happens with, let's say, like the mountains, and as well as any far buildings. And there's also the near shading, that also, as the name suggests, it's regarding all of the near objects, including trees, houses, that could be blocking, the sun from reaching any PV cell. But again, if you are interested about the near shading, this is actually something that my colleague did a couple of weeks ago. So if you're interested in watching this webinar about near shading, I strongly suggest you that you go to our website so that you can watch that complete video. But for today's webinar, the focus will be regarding far shading losses. So starting with the definition of far shading and horizon profiles. So we can define as far shading or horizon the type of losses that occur on a macro level of the PV plant that can be due to mountains, very distant buildings, or others that could be blocking the direct radiance of the sun from reaching the PV plant. And so we have here an example. You can see here that our PV plant is right here in the middle, and on both sides, left and right, we have some mountains, right? And then those mountains will actually cause some shading to our PV plant. Now talking about the horizon profile. So basically the horizon profile can be defined as the chart representing both the trajectory and the elevation of the sun, as well as any mountain or far buildings that could be blocking the sun from reaching the PV plant. So if we take a look here in this horizon profile, we can basically see two axes here. So we have the first one, the vertical, regarding the elevation, and then we also have this on the horizontal axis, which is the azimuth. And if you also look here, there's other information profile is given us, such as the hours, right, where the sun is going to start. Here it's starting at 6 a.m., going all the way to the other side until 8 o'clock p.m. And it will also give us some other information, such as the different trajectories or different path that the sun will be going through throughout the entire year. And if we also look here on the right side, we'll also be able to see the equivalent months that will correspond to those different layers here, right? So we can see here starting from 1 all the way to 7, which is also what we're seeing here. And basically, what will determine the horizon profile is going to be the specific location of your site, right? So here on the left, we can see different lines. So this middle one is the equator line. And then we also have other lines here. And depending on where your site will be located at, it will have its unique profile. So now we have a poll question here, and taking into account this specific horizon profile, the question is the site of this horizon profile located above or below the equator line? So we'll just give it a couple seconds so that you can see the image. So basically here, in case you cannot see very well, we have here the number 1, which will have the highest sun hours and is accounting for June. And then we also have this lower level here accounting for the shortest sun hours, which is going to be December. So is this site going to be above or below the equator line? So I guess we can start with the poll. And let's give it a couple seconds so that you guys can actually answer this. Okay, I guess we can close the poll. Alrighty, and I can see here that the answer is, or the majority of the people here selected that the site is above the equator line, and the answer is right. The site is actually located above. And on a very brief explanation, so basically, if you are above the equator line, you will see that the winter time, right, where we have the lowest sun hours, will basically occur on the months of November, December, January, and the summertime will be happening on the months of June, July. And for the cases where the site is located below the equator line, then this order will be changed, right? So we will have the summertime during the months of November, of December and January, and the winter time during July, June, and etc. So good one on that. Let's jump into the next slide. And basically here we'll be talking about the different types of horizon profile. Like I mentioned before, so depending on the location of your site, will be having different horizon profiles. So in this case, starting with this first one, where it is located at a latitude greater than 66.5 degrees. And then we can see the second one, which is probably one of the most common horizon profiles. And this one is located at the latitude between 23.5 and 66.5 degrees. Then we also have this one, which is between 0 and 23.5. And then last but not least, we have this one, which is going to be close to 0 degrees or also close to the equator line. Now, basically here, I'm just showing you this image that we had seen before. And we can see that our site is being affected by these mountains. And we also have here on the right side its equivalent horizon profile. And we can clearly see that this gray area will be accounting for the shades or this mountain elevation here. And you can also see that when where the sun is actually rising on this east side, we have the highest elevation of the mountain. And then on the other side, on the left side, we still have mountains, but on a much lower elevation. Now we'll be going to show you, or I'll be going to show you how to optimize far shading losses in PV design. Let me actually go up here. So I already have a site ready, which is exactly the site that we were just seeing. Okay. And again, this site is located right at the equator line. So basically, there is a few things that you can do to optimize your system, taking into account far shading losses. So one of the first one is that you need to identify the type of structure that your system is actually using, right? So if we are using a fixed structure, then basically there's two ways that we can actually optimize. We can start with the first one, which is going to be changing the azimuth of the structures here. And basically what I can do here on PV design is simply clone these already generated design. I'm gonna go to layout. Give me a few seconds here. Then I'm gonna go to layout configuration. And then I'm gonna go here all the way to rotation, rotate, and then I'll change this turning angle. Now, this site is, even though it's still on the equator line, it is located slightly below. And then we have here our panels facing north. So if I have a lot of shades from the east side accounting these mountains, and I have my panels facing north, then the ideal case would be to have them oriented or rotated towards the north and the west side, right? Because here on this specific side we have a lower elevation, and so we should be getting more light from this side. So basically here I'm going to run 3 different iterations, right? Changing this azimuth so that we can see how it is actually affecting our energy yield. So let me start with a -5. Let me refresh our layout so that we can see how it is actually changing here. Okay, so we can see it is actually going to the north and the west side. So let me generate that really quick. Add the node here. And then like I mentioned again or before, I will be doing another 2 iterations here, changing that. So I'm gonna go to layout. Now I'll be changing that to -10. I'll do generate. And then I'll also be doing another rotation, which will be, let's say, -14. I'm just adding those notes here so I can clearly see them or identify them after I have all of the designs ready. So there's just 2 more here waiting to be generated. Let's just give a couple more seconds. This is very quick. Okay, so we already have all of the designs ready. I'm going to click here to select all of those 4, and then I'm going to use this feature to compare so I can analyze how those designs are changing, right? So I'm just going to scroll a little bit down here. I'm going to put these nodes up so I can see which one has what type of azimuth. I'm going to change the energy here. Then I'm also going to change the order of how I see that. So I can have it going from the highest energy production to the lowest side. And as we can see here, as I change my azimuth towards the north and the west side, my energy yield is also increasing that, okay? So the ideal case is that we would continue to run different iterations, changing that azimuth until we reach that peak level, right? Where we'll be getting the highest energy production. And then from there, we can proceed to other things. Of course, if you keep rotating that, there will be a point that the production will start going down. So you just need to find that peak value, and you should be good to go. Now, the other thing that we can do to optimize our designs, taking into account for shading, is going to be uploading a horizon profile. So let's say that either your company or a subcontractor company, let's say that they conducted a survey in that particular site, and they were able to provide you with a horizon profile. Here in PV Design, you actually have that opportunity to upload your own horizon profile. We will provide you with the horizon profile from PVGs. But if you think that the information here is actually way less than what the site actually is, you can upload your own horizon profile. And if you have any questions about how you actually need to do that, you will simply click this how to link, which will take you to our knowledge base articles. And then from here, you will be able to, gather some more information about it, including download that template for the horizon profile so that you can insert those values and upload to PV Design. So I'm just going to upload the horizon profile that I actually have. So let's go here. Okay, and just so that you can, in a very brief second, see the difference here. So this is the one that the software would be given to you. We can see some high elevations. And then let me quickly change to the one that they say that we gathered this from the survey. Alrighty. And so basically right now, what we can do is generate another design with the new horizon, generate design. Let's give it a couple seconds, and then we'll be comparing those two last iterations. Okay, so we have both our iterations here ready to be compared. So I'm just gonna select those two, click this button, and then move these nodes up so I can know which one is which, as well as change my energy. And then let's see what we have here. So we can clearly see that updating the horizon profile, we were actually able to significantly improve or increase our energy yield, right? So again, this is just one of the few things that you can do to optimize your system. And then I guess we can get back to the slides. So on a brief summary here of what we did. So we had this one, the first design facing north with the azimuth 0 here. And then we have all of the different iterations that we actually did. And then there's also this one that I did not generate this specific one on the webinar, but we can clearly see this one here where we are not considering any horizon profile, completely flat. And of course, we're getting a much higher energy yield. The question would be, would this be accurate? Would this actually be representing what our site actually has? We know, right? Because we have mountains on both sides. And so if that's the case, then it's always best to use a horizon profile. If you don't have one from the survey, you can always use the one that that PV design will be given to you. And another summary of what we actually did here. So one of the first things that you need to be doing is identify the type of structure that your site is actually using, right? You can upload that horizon profile. And then in case you have a fixed structure, then you can change the azimuth. If you have a tracker or an east and west side, changing the azimuth wouldn't really make much of a difference. And in fact, it can actually decrease your energy production, right? So this should mainly be used if you have a fixed structure. So I guess this is it for the presentations here. If you guys have any questions, please feel free to ask. Okay, I see that we have one question here, and the question is, can we model trees or other near objects on far shading analysis? Well, technically, we can model trees, but should we? The answer is no. And the reason is because those are two different models, right? So the near and far shading, and therefore those will affect the PV system on a different level. So on the near shading, we're basically studying, maybe particular panels, right? Maybe it's being affected by a tree, and so it's not going to be affected on a macro level compared with the far shading, let's say like mountains causing shading to our site. So technically we could, but we shouldn't because those are two different models. Um, let's see if we have any other question. Oops, sorry. Okay. Okay, I see another question here. So if I change the site on PV design to another area, will that affect the horizon profile? That's a good question. Um, let's actually go to PV design. And let's change the site to another location. Okay, so by the way that we can quickly change this is by coming here to the site. Let me clone this design, and then let's go to, let me change that to another area. Let's see. Let me choose an area where we don't have very mountains. Okay, let me probably try. Okay, let me probably try this side here. Okay, so I'm just gonna draw the area here. Okay, let me generate this design. So basically right now we're trying to see how changing the site is going to affect our horizon profile. Okay. Using the newest one right here. Okay, now one of the things that we can do to check that new horizon profile is actually click here on the energy. Let's go to horizon, and then let's see what the horizon from PPGs will actually be. And as we can see, it is actually different than the one that it was showing for the previous site. And it actually makes sense because again, we don't have any mountains here or any significant far shading elements. So that's why that gray area is actually very, very low. So, alrighty, so let's go back to the slides. So I see one question here. So basically in a hybrid project, solar and wind, how can you add the shading losses generated by the turbines. So this is an interesting question. I would say that it just depends, right? Let's say like how many of those turbines are actually there. But ideally, because PV design currently for the near shading, it takes into account inter row. If you actually try to use that, you would need to use a software that can actually run the 3D analysis, all right? Taking into account those specific turbines. Okay, so that would be my answer for it. Let's see. Okay, let me see if there's any other question. Okay, all right, so I don't see any other question here. So is this software the PV design belongs to RatedPower? Yes, so PV design is a RatedPower software. And it has focus on specifically utility scale solar projects, feasibilities, analysis, energy yields. Um, but yes, it's a RatedPower software. Let's see if there's anything else here. Okay, so I don't see any other question here. So again, if you guys have any other questions, please feel free to drop here, or you can always send us an email and we will be able to reply to you as soon as possible. This webinar will be ready for you to rewatch in the end or a couple hours after in case you started late or you would want to, gather some other information. You will be able to actually see it. So thank you guys so much for joining this webinar. I hope it was very useful and insightful regarding fog shading. And yes, thank you.